Saxon Algebra 2, Lesson 105. Students, look, we're beginning the third week. By the end of this week, we'll be at the halfway point between spring break and summer break. Sorry, I can't talk. I feel good about that. I'm glad this time is zooming by. I will miss you over the summer, but I will look very forward to reconnecting with you in the fall and continuing our adventures in mathematics. Let's talk about lesson 105. It's a gem, you guys. And I'm going to just tell you, a lot of students have a hard time remembering this. So I'm going to try and make this a memorable lesson because I want you to remember. I'm going to start by going a little bit backwards, or just starting at the beginning. That is what we call the standard form of a trinomial, right? You've seen this 100 times, you know. Sometimes we put equals 0, sometimes we don't. That makes a big difference in some ways, but for what we're going to be talking about today, it doesn't make any difference if there's a 0 there or not. Okay, so expression or equation, this works exactly the same way. Now, we know some ways to factor this, to break this down, right? The first way we learned how to do it is by inspection. All right, and that's the thing where you find two numbers that they have to do two things, right? They have to multiply. That's not a minus sign. They have to multiply to C, whatever a plain number is, and they have to add to B, the value of the number in front of X, right? We've been doing that for a long time. You've been doing that since the middle of Algebra 1. That's easy. But this works only when A is equal to 1, right? If there's a number here, that screws us up. A number that isn't just an invisible 1. Now, sometimes John plays a trick and he'll do something like this. 3x squared plus 3x plus 6, right? He'll be like, wah, look how hard I made this. Well, but this is easy because we can just divide every term by 3 and we get x squared plus x plus 2, right? So then we're back to having when a equals 1. So this is kind of just like a little trick scenario. But it still fits this general rule, which is that A is equal to 1, because it ends up being 1 after a simple little adjustment. What we're going to do is find a way to work these problems when A is not equal to 1. Okay? So that's what we're going to be working on today. When A is not equal to 1, it can be any other number that works. That's what we're going to talk about in this lesson. But I just want to go on and explain to you. The second way to do it is by completing the square. Go ahead. I hear you groaning. We're not going to complete the square today. Oh, now you're smiling. And then the third way is by the quadratic formula. These will also both work when A is not equal to 1, right? It doesn't bother us if we have a number for these. So we can always use this tool, but it's nice when we can just look at a problem, right? Because that's what inspection means, is just looking at it, and solve it, even if the numbers are a little bit bigger. So this is our goal today, but I want you to always remember that completing the square and using quadratic formula always, always, always work. And this is just a nifty little trick that sometimes works, but it works in more scenarios than what we've learned up till now. Okay, remember that the rule is you find two numbers that multiply to this and add to that. That's always been our rule, right? But for advanced, what I'm calling advanced factoring by inspection, we're going to take this rule and we're going to change it ever so slightly. Step 1 is find two numbers that, right now you're thinking, it's the very same thing. Why are we writing this all over again? Here comes the difference. Instead of the two numbers having to multiply to just C, they have to multiply to A times C. We multiply them together, okay? Then the second part is exactly the same. They add to B. All right, so this is what's new today. And then I'll show you how to solve it from there. But this is the mind-blowing part. Well, that's the main mind-blowing part. And I think we learned this last year because the Algebra 1 gentlemen are learning. They're getting ready to learn this too. So you learned this last year. But this is the way the rule is different, is that we have to multiply A and C together before we come up with our mystery pair. So let's practice. Won't that be fun? I'm excited. I can't wait to practice. Ready? Factor 6x squared plus x minus 2. Okay, they're in order. This one does not have an equal 0. It's just an expression. That's fine. For the purposes of factoring, it doesn't make any difference. I'm going to put a 1 there just because sometimes that helps me if I see the 1. And the first thing I'm going to do is I'm going to figure out what is A times C. 6 times minus 2 equals minus 12. Remember, the sign matters. All right, so we're looking for a pair of numbers that multiply to negative 12 and add to B. B equals plus 1. Okay, and let's see, that looks like it would be plus 4 and minus 3, right? Because they multiply to minus 12 and they add to plus 1. Okay, good. Now, before we were ready to just go right to the buckets, this time is different. Step 2. This sounds weird, but it makes sense. Into, that's one word. What we're going to do is we're going to take these numbers and we're going to rewrite this term. We're going to make it into two terms that will equal that. That way we won't be changing the expression. All right, so if I write plus 4x minus 3x, would you agree that minus 4x plus 3x is just a long-winded way of writing plus 1x? Because if we combine them, then it's positive 1. So I'm splitting those. There's a method to my madness, but really I'm just taking something simple and making it a little bit bigger. The first term stays exactly the same, and the last term stays exactly the same. We just copy them so that we've split the middle into two terms, and now the third part, step 3, this is what I just taught a lesson to Jackson and Caleb. Factor by grouping. Factoring by grouping is what we do when we have 4 terms, and what we do is we look at the first 2 and we look at the second 2. And we're going to factor those individually. Now, right here is where my student brain blew up because I thought, how do you know which one to write first? Should you write the 4x first? Or should I have written it minus 3x plus 4? Spoilers, it doesn't matter. You can write these in either order as long as they fit, our 2 rules that they multiply to AC and they add to B, then it's fine. It doesn't matter. And I'll show you later probably that it works out both ways. Okay, now we're ready to factor. What can we pull out of these numbers and letters that they have in common? 2x, right? And what does that leave us with? 3x plus 2, right? And then you can always check your work by distributing. 2x times 3x is 6x squared, check. 2x times 2 is 4x, check. Okay, I did that right. Now, remember that when we factor the second half, if we are working accurately, we should get this same expression again. And so I'm comparing this to this, and that kind of helps me see what the factoring is. I see that there are a problem with the minus signs, right? The numbers and letters are the same. But these signs are negative and I want to turn them positive. Okay, so let's just factor out a -1. And that's going to change the signs, right? That will give me the 3x plus 2 that I want. And the final answer, I call it the art project because all we're doing is just making it look nice. I take the part that's outside the matching quantity and I create that into a binomial. And then I write this again. I can just write it once. I don't have to write it twice. That's my final answer. Advanced factoring. Again, we could use the man-eating dragon or completing the square right here. We don't have to do it this way, but I think you will agree this is easier and a little bit more fun than doing either of those medieval torture methods. Let's do another one. (2x squared minus 7x minus 15). Okay, first step, we find the two numbers that multiply to give me a times c, which is -30, and they add to b, which is -7. See, I was already guessing this because I can see it's 3 and 10, because they have a difference of 7. They multiply to 30. I'm going to need a minus sign. It's -7, so I know the minus goes on the bigger number. Okay? Now, it doesn't matter which order I write them in. If you were with me, I'd let you choose. I'm just going to write them in the order I thought of them. So it's going to be plus 3x minus 10x. Remember, we need the x because it has to match to that, right? We're splitting this minus 7x into two pieces. These two can combine and they're the same. So I'm not changing anything. I'm just creating two terms in the middle so that I can factor beautifully. The first and the fourth just fall straight down. They don't do anything different. And this is minus 15. And then we're going to factor by grouping. What can I pull out of this? Just an x. And I'll get 2x plus 3. And I see the signs are going crazy on me here again. I'm going to want to pull a negative out, right? Because I want these to turn positive, and I can see I can get a 5. So if I pull a -5, then that's going to leave me with a positive 2x and a positive 3. Okay, so be careful when you see those signs going your wrong way. Use a minus in what you pull out, and that will change the signs. All right, art project, x minus 5 quantity, 2x plus 3 quantity. I haven't been checking my answers. I just know if they turn out right, everything must be fine. 2x plus 3, x minus 5. That's right. Now, here's the interesting thing. If I would have written this down, let's just do it. If I would have written these in the other order, 2x squared, I'm just going to flip these around. Minus 10x plus 3x minus 15, right? I wrote those in the opposite order. Let's just factor them in this order. Here, I could take out a 2x, and I would have x minus 5. And here, I could take out just a plus 3, and I would have x minus 5. Look what happened. Last time I had 2x plus 3 on the inside. This time, my 2x plus 3 is on the outside, if you will. Last time, my x minus 5 was on the outside. This time, my x minus 5 is on the inside. So it just changes the order of the binomials, the way they appear to you, but you'll get the same answer, right? Because I would fix this to say 2x plus 3 times quantity x minus 5, and that's exactly the same as this. Order doesn't matter in multiplication, okay? That's proof that the order that you write those middle two terms in doesn't matter. It'll work out fine either way. If you see a pattern that you get excited about and think, oh, that would be easy to factor, go ahead and put it the way you want. You can definitely do that. But if you're just plodding along in your problem and you just put them down any old way, it'll still work out. Okay, one more. Ready for John to be a smart aleck? How do you like that? Isn't that cute? He messed it all up. So, all right, fine. Let's bring this back over here. As we change sides, it will change signs. We'll have 6x squared minus 5x minus 6 equals 0. Now, I told you this before. This doesn't change anything. It just gives us a little more work to do at the end. But in terms of the factoring, this doesn't make any difference. We use the very same process. Okay, so let's find out what a times c is. That'll be minus 36. And b is minus 5. Okay, so we're looking for two factors that multiply to minus 36 and have a difference of minus 5. 18 and 2 is not going to cut it. 9 and 4, how about that? We'll need 1 to be a negative to get the minus here, and we want it to be the bigger number. So how about minus 9 and 4? All right, and I'm just going to use them in this order. I'm going to split this out, just like we have been doing. It'll be minus 9x plus 4x. Sometimes students will forget that x. Remember that all this work we're doing is just on the coefficients, but we need to keep it's the x term that we're playing with here. So go ahead and tuck that in. And then the first and the fourth stay exactly the same. 6x squared minus 6. And I'll just copy the equal 0. Again, it doesn't change anything yet. Factor those two, factor those two. We can pull out, what, a 3x. And we'll have 2x minus 3. Plus, we can just pull out a 2 here, but look what we get. 2x minus 3, it matches. Just copy that. Now I do the art project. 3x plus 2 quantity times 2x minus 3 quantity equals 0. Okay, now we're ready to go on. This is where we stopped last time. Now we're ready to go on from here. It's not much harder. We use the zero product theorem to say that if these two things multiply together and equal 0, then either this one or that one is equal to 0. So we say 3x plus 2 equals 0 or 2x minus 3 equals 0. And then we hit this with an algebra stick. I swim the 2. 3x equals minus 2. And I divide by 3. So we get x equals minus 2/3. And then over here we do the same thing. Swim the 3. 2x equals 3. Divide by 2. X equals 3/2. There are our two roots, solutions, values for x, whatever fancy name you would like to call them. But that is how we take, in the first two examples, we did not have it as an equation, we just had an expression. If you have the equation, you go ahead and factor it the very same way, and then you just take this final step of solving for them. You got this. Okay, guess what? That's the end of lesson 105. There's nothing more I can do to drag this out for you. I'm sorry, I have to stop here. Isn't that sad? Okay, thank you. Goodbye.